In this video, I want to go over complex numbers and the math constant I. First, let's talk about I. If I'm wondering what the square root of negative 25 might be, well, you might say to yourself, okay, maybe it's 5. Well, if that's the case, then 5 squared must be negative 25. And let's see if that happens. No. Okay, so the next natural one would be negative 5. Is negative 5 the square root of negative 25? And the answer here again, negative 5 times negative 5 is a positive 25. So that doesn't work either. What mathematicians decided to do, this was way back when, in the 1500s, a guy named Cardano decided that sometimes you would run into this problem when you're solving things, and he decided to give this problem or this issue, we'll say a name or a math constant. He decided to define the square root of negative 1, okay, as I. And what that did was it solved things like this. So you could break up the square root of 25 into the square root of negative 1 and the square root of 25 and get your answer as, well, the square root of 25 is 5 and the square root of negative 1 is I. So you could get your answer of 5I that way. But in the 1500s, Cardano did not, he thought these numbers were useless. In fact, they're not, but that's why they're commonly called imaginary numbers, okay? It's a throwback to that time when mathematicians and scientists didn't know the power of these numbers, so they just called them imaginary. Another word from that time period is impossible numbers, and at the time mathematicians did not have many good things to say about them. Now it's very different. They're used all over the place to solve very complex integrals. They're all over physics and science, and they're very important. But this was the basis, and the person that decided that they were actually useful was another Italian. Cardano was Italian. Another Italian was named Bombelli, and he was solving a cubic equation, and he, in one of his mid steps into solving this, he came across some imaginary numbers, and he had to solve that in order to get his final step or his final product. So he had to use these imaginary numbers within the steps to get his answer, and that's when it kind of came to light that these imaginary numbers do serve a purpose in our mathematics. You'll also see the square root, or I defined sometimes like this. Okay, I squared is equal to negative 1. Actually, you'll see this more often in textbooks, but you can think of I as the square root of negative 1 for this class. Okay, moving on. There is a pattern involved in I with these numbers. So, let's talk about the pattern. So we know that I is equal to the square root of negative 1. All right. What do you suppose, and I'll do this one in green, what do you suppose I squared is? Well, I squared is square root of negative 1 squared. Squaring and square roots are inverse operations, so they can go away, and I squared is negative 1. And we saw this earlier. Okay, let's move on to I cubed. Let's see what I cubed is. Well, I cubed is I squared times I, right? So we can write that as -1 times I, or negative I. What about I to the fourth? Well, I can write that as I to the second times I to the second, and that is -1 times -1, which is 1. Let me just write this out for you. Here are our results. We have I, and you have -1, negative I, 1. Okay. What about I to the fourth? Or I to the fifth, sorry, I to the fifth. Well, that's just I to the fourth, which is 1 times I. So that's 1 times I, which is just going to be I. Let's do I to the sixth. Well, that's just I to the fifth times I. I to the fifth is I. I times I is I squared, and we know I squared is -1. So if you see, we're getting a pattern here. So the pattern goes I, or -1, sorry, negative I, and 1. And then it's going to just keep on going. So every 4, the pattern starts again. Okay, so if I said, okay, I to the 12th. Well, 12 is divisible by 4. Okay, so we can really consider this I. Right, and consequently, I to the 13th is going to be the next one in the pattern, and so on. All right. I want to show you a few problems. We'll do a few problems and go through how I would solve them. Okay, these are our problems. We have I to the 41st, I to the 5,420th, and 1 over I to the 13th. And we want to simplify these. The directions are going to be to simplify. And a very important little multiplication trick is that if a number is, if the last 2 digits of a number are divisible by 4, then the number is. Okay. That's going to help us out with example number 2, right? 5,420, 20 is divisible by 4, so that's going to be divisible. 5,420 is also going to be divisible by 4. Okay, let's do I to the 41st. What I commonly do is I break up the exponent, right, using my rules of exponents, into a number that is divisible by 4 and whatever's left over. So I know that 40 is divisible by 4. It's the lowest, or it's the closest number divisible by 4 to 41. So really that's equivalent to I to the 40th times I to the 1st. All right, well, I to the 40th, since that's divisible by 4, that is going to be 1, right? Every number that's divisible by 4 is going to be 1. That's not to say that every number divisible by 2 is negative 1 and every number divisible by 3 is negative I, just that every number divisible by 4, every exponent divisible by 4 is going to be 1. All right, so we have this. We have 1 times, well, I to the first is just I, so our answer here is just going to be I. The next one, we have I to the 5,420th power. Well, I know that 5,420 is indeed divisible by 4. Actually, let's make this problem a little bit more interesting. Let's make it 5,423. All right, so I can break this down into a number that I know is divisible by 4, which is 5,420, times I to the third. Okay, well, I to the 5,420, that's just 1 because it's divisible by 4. And I to the third is negative I. So this answer is going to be negative I. Next problem. 1 over I to the 13th. Well, you can do this a number of ways. I'm going to just simplify the I raised to a power down here, and then we'll see what we can do. So I to the 13th is equivalent to I to the 12th times I. Okay. I to the 12th is 1. I to the first is I. So we're going to have 1 over I. Let's see if I can do any better than that. Let's multiply everything, both the top and the bottom, by I. So that's going to give us I squared on the bottom, which is negative 1, and I on the top. So this is going to be negative I. And this step here, I'll talk about in the next video. Okay. Now on to. Actually, I'll make another video for complex numbers.